Salutations. Welcome to Chem Vid reaction rates. Today we will be discussing the rates of reaction. If you notice on your notes, it says write Y for every question. That is because you can answer these questions in about 2 words, some of them, but the really important part is knowing how to answer why. So make sure you have the why for everything we do today. Alright, the first part of this video comes from a TED Ed talk that you can Google, or not Google, YouTube. If you type in how to speed up a chemical reaction and get a date, it'll bring up the TED talk and you can fill in these lovely bullet points on how to speed up a chemical reaction. So I'll give you a moment to do that. Alright, the next thing I need you to do is I need you to read this information and actually read it, because I'm going to use it and I need you to understand it. So please read this information and we'll get going. Alright, questions number 1. What is molarity? Well, we learned that last time. Molarity is moles per liter. Moles of solute over liters of solution. It is a percentage, and it tells us how concentrated a solution is. What symbols are used to represent molarity in the above equation? So if I look up here, it says that the rate of disappearance of reactant A is equal to the change in molarity over change in time. So if I look over here, they have change in brackets, reactant A. Those brackets are another way of saying molarity. So if I wanted to say 2 molar, that's the same thing as writing 2 in brackets. So this means 2 molar, this means 2 molar, they both mean moles per liter. Alright. In the above reaction, where are the units? Well, we have change in molarity over change in time. We know that molarity is moles per liter, and we know that time is seconds. So our final units are moles per liter seconds, or molarity per seconds. Number 3. How is the change in molarity calculated for a reactant? So let's look. If I have the change in molarity for my reactant, that's going to be just like temperature final minus temperature initial is change in temperature. This is molarity final minus molarity initial of your reactants. Okay, no big deal, just like temperature, we're just doing concentration now. Because a rate is how much the concentration changes per time. Alright, the second part of this equation is, would this be a positive or negative value? So if you're thinking about your reaction, and you have your final concentration and your initial concentration, what happens to your reactants as a reaction occurs? Well, you start off with lots of it, right? So your initial amount is a very big number. You're going to start off with 10 moles per liter. Then, as a reaction occurs, the reactants go away, right? They turn into products. So if they're turning into products, that means they're going away, and your final concentration will be low. Low minus big means that the change in molarity for a reactant is a negative number. Alright, so now in number 4 they're asking the exact same thing, only for products. So we know that change in molarity is molarity final minus initial. So I'm just going to write out change in molarity for products. However, when you're doing products, you start off with none, right? We start off with 0 initial molarity, and we start making products, so we're going to actually make something bigger. And so if I have big minus small, the sign will be positive. So a negative is because we're losing reactants, positive because we're gaining products over time. Which brings us to number 5. When writing the equation for the rate of formation of product, the negative sign above the formula is not needed. Why? So let's scroll back up. If you look over here, a reactant, they had to put in this negative sign right here. And as you read, all rates have to be positive. Why? Because you can't do something backwards. Like, think of like the rate at which you drink water a day. All right, you drink, 8 glasses of water per day. That's your rate. You can't, if you don't drink any glasses of water, that's 0. But you can never have a negative rate. So we need to make the math match our understanding of chemistry. And so for that, the reason why we need the negative sign here is because we know that if I take a final minus an initial, it's going to be a negative number. So I'm going to have to multiply it by a negative number to get a positive rate. Whereas the products is already positive, so I don't need that negative sign there. Very important to understand. All right. Number 6, let's put this into action. I want you to read this number 6, and I want you to try A, and B, okay? And see if you can get it before you watch the rest of this video. So I'll pause, you'll pause, and I want you to give it a shot. All right, so now that you've given that a shot, let's look at A. The rate of hydrogen is equal to the change in concentration of hydrogen, so the change in molarity, which we symbolize with brackets, over the change in time. So I read through my problem, and it said that hydrogen went from 0.03 molar to 0.02 molar. So I do final minus initial. And then it also says the reaction occurred for 4 seconds, so I divide by 4 seconds. That gives me 0.01 over 4 seconds, and it's negative, which gives me a total rate of 0.025 molarity per second. However, there's something we're missing. Remember, math is only good for numbers. It doesn't do the thinking for you. Hydrogen is a reactant, and like we said before, reactants decrease. So it may appear like it's a negative rate, but we need to make it positive because we know we can never have a negative rate. So what does this number mean? This number means that when you react hydrogen and chlorine to make HCl, 0.0025 moles per liter of hydrogen are going to be used up in the reaction every second. Okay, so this tells you how much reactant is used up every second. All right, so go ahead and if you haven't done B, or if you did B incorrectly, do B now. All right, so B is the exact same thing as hydrogen. So chlorine and hydrogen are used up at the same rate because their difference in concentration was the exact same number and it was the exact same amount of time, so we get the same number. Now if I look at C, C says calculate the average reaction rate expressed in moles of HCl formed per liter per second. So I'm thinking about it, and HCl is being produced, but how fast is it being produced? Okay, I have this equation. I know that for hydrogen and chlorine, I go 0.0025 molarity per second. Well, what is my HCl? Well, this is where your dimensional analysis comes in. I know that it takes 0.0025 moles, that's an M, per liter per second, correct? That's how much we're making of hydrogen. Then, just like with any balanced chemical equation, I can go from moles of hydrogen to moles of HCl. So if I look at that wonderful equation, it says H2 plus Cl2 goes to HCl. What is the first thing I need to do in order to get this relationship? I need to balance the equation. So H2 plus Cl2 goes to 2HCl. Now that I have my ratio, I know there's a 1, I know there's a 2, and I'm going to multiply that by 2. And the rate for HCl is equal to 0.005 molarity per second. All right? So with your rates, just like in thermodynamics, you have equations that you follow, but you also use your dimensional analysis to go from moles to moles, just like we did before in stoichiometry. So don't let that mess you up. All right, so then it says, what concentration of HCl is present after 4 seconds? Go ahead and pause, see if you can figure that one out. Okay, so we know that the rate of HCl is 0.05 molarity per second. Remember, that means that 0.05 molarity, or moles per liter, is being produced every second this reaction occurs. So if I look at this, I know that there's 0.05 moles per liter per second. And if the reaction continues for 4 seconds, like it said, well, the seconds cancel out. And I'm left with moles per liter, which is a concentration, which is what they're asking for. And I do my math, and I get 0.02 moles per liter is present after 4 seconds. So you have your rate, you have your time, multiply the two, and you get your concentration. All right, so calculating rates is important, and you'll have to be able to do that, but understanding why they occur is probably the bigger picture. So what I want you to do is I want you to read through the material, and we're going to go over it. Make sure you read through it, try to understand it, and we'll go over it. All right, so collision theory has two main parts. Molecules have to collide in the correct orientation for a reaction to occur, and they have to collide with enough energy. We call that activation energy. So if you looked in your diagram, carbon monoxide and nitrogen dioxide, if they face each other in the wrong way with the negatives coming towards each other, they're going to repel and break apart. They're not going to react. But over here, if you have a positive with a negative, and they come together, they're going to attract one another, and this reaction can occur because they actually want to be next to each other. We learned how to tell if things are positive or negative using Lewis dot structures. So that's how we determine correct orientation. Now the second part is they have to have enough energy. So if I'm going to draw a quick example. Okay, so I rewrote it so we can see it better. Hydrogen, these bonds right here, in order for a reaction to occur, they have to break, correct? So these guys got to break, these guys have to break. And then this guy will form. So does it take energy, or does it release energy for bonds to break? If you said that breaking bonds was endothermic, you are correct. It takes energy to break those bonds. So we have to absorb energy to break these bonds, and then we release energy when we form new ones. So our overall reaction depends on if it takes more energy or if we release more energy. Exothermic releases energy, so that means that there was more energy given off after you formed the bonds. Endothermic means there was more energy absorbed than was produced when you produced the products. All right? So in collision theory, when we're talking about there needs to be enough energy in order to start the reaction, that's what we're talking about. It's the energy to break these bonds. Okay? So it's enough energy to break the bonds so that they can start reacting so they can form products. All right, so now we've seen what has happened in chemical reactions. Your assignment is to finish questions 1 through 6 below. Make sure you include why. Make sure you are trying to understand what's happening. And if you need help with Lewis dots, YouTube, notes, or come and ask me. All right, good luck.